Quite steady. Quite steady. Wine hả? Hơi lớn. Wait 1 more minute. Yeah, you got a question? You mean last lecture, is it? Yeah, I haven't done it. Yeah, I'll do it soon. Okay, thank you. Is he like having a big one? Ah, okay, let's not wait then. Okay, so good morning to everyone. Hope you guys have a fresh start. Finish all your midterm, is it? Not yet. Still got one more. Okay. Good luck. Um, yeah. Before we start, um, so you guys, so I prefer you to call me just Kiseng, okay, when you talk to me. I mean, in formal situation, you can call me sir, doctor, or professor, but professor, strictly speaking, I'm not a professor yet. So a bit uneasy when I hear this. So you just call me Kiseng, because I respect the culture where I obtain the knowledge, right? So I studied in Australia, where they just call the lecturer by name. So the idea is like you treat your lecturer like a friend, okay? So that's not much different between you and me, okay? I just know a little bit more than you, okay? Who knows, later you know more than me, right? Okay. So having said that, it's kind of similar to the Chinese philosophy, right? Like teacher, like friend, 亦师亦友, okay? So in Western, we they they focus more on this friendship part. But so having said that, I don't want you to think that whatever I say is absolutely correct. Okay, because this is not good for the development of the academics. Right. You can see that for Newton, gravity, it governed for a few centuries. Okay, people think that it's true, but it's false in some situations. For example, when you test the orbit of Mercury. Okay, then Einstein come up with the general relativity to describe the gravity. But there are still some flaw inside this theory, right? So we cannot test what happened inside the singularity, inside the black hole. So knowledge is keep renewing. So please don't treat everything is true. Just like what I tested you in the first part about my exam, right? I give you a statement, okay? Decide whether this is true or false, okay? When it is false, give me a counterexample. Okay? Prove it. So usually counterexample is easier to construct, usually. Okay, because you just need to construct one example. If you want to prove something is true, then you need to prove for all cases. Okay. This is exactly how the Calabi-Yau manifold being discovered. So Calabi conjecture asks, okay, I don't want to mention about the maths term, like the curvature stuff. So in physical form, it will ask, does a vacuum without a mass possess gravity? Okay. So Yao started attacking this conjecture using counterexample. Okay. But it failed. Okay. So he turned to prove that there exists such space without matter, but it has gravity, okay, which is we call the Calabi-Yau manifold. And it consists the extra six-dimensional space of the string theory nowadays. Okay, so yeah, so try to be critical. Okay, that doesn't mean that you try to critique your critique the how to in a bad way. Okay, but you must have a critical mind. Okay, when people speak, you have to have a critical mind. That doesn't mean that you need to like fight with people. It's not like that. but I want you to have a critical mind. Does it make sense? Does it make sense? Okay. Okay. So I want you to try to look at stuff differently. Okay. I haven't finished your exam marking yet, but hopefully I'll done by next week, then we will discuss together. Okay. Yeah, so I still encourage you to ask questions. Okay. So during exam time, actually quite a few of you ask good question. So you should do it during the lecture. Okay. Don't wait until last minute. Okay. Don't procrastinate. Don't wait until last minute. Okay. Always do the exercises. Whenever you have problem, you should point it out. Okay. Yeah, don't wait until last minute. All right. So I haven't posted out the lecture note for last lecture. I'll do it soon. Okay, I'll do it soon. Okay. Okay, so we'll continue with the business of partial derivative. So last time, where do we stop? Let's recall where we stopped. So we stopped at chain rule. Okay, the second case of chain rule. Okay, we stop second case of chain rule, where we have a function in two variables. Okay, and then in the variables we express in another two variables. Okay, and then we want to try to differentiate with respect to the new two variables. Okay. So let that be a function, two variable, okay, and it is differentiable. Can anyone recall what's differentiable mean? Hey, when Ellie appears, how you appear? From the back? Oh, I didn't notice. So can anyone recall what's differentiable means? Linear. Okay, what's the keyword? Linearization. Okay, you have a linearization at the point. Okay, at every point. Yeah, you can approximate your surface using a plane. Okay, using a tangent plane. Okay. So if you want to look at the definition, it's involving the epsilon and delta. Okay. So morally, you can estimate your surface using a tangent plane when you zoom in and zoom in more. Okay. Yeah. So when you do epsilon delta, it's actually you are zooming in the curve. Okay. It's just a mathematical way to talk about it. So let's say I have a function that's differentiable at any point. Okay. And then we can express our x and y in terms of another variable, right? Since we want to do chain rule. Over, they have the first partial derivative at O point, okay, at every point as t. Okay. Now we want to differentiate our z with respect to s and t. Okay. So how do we differentiate with respect to s and t in this case? So how do we differentiate with respect to s and t? Remember the tree we drew last time? Okay, so how do we draw the tree? We start with a function, okay, z, right? So we can start with the z, and then z is defined by two variables. Okay, it's defined by two variables. And then x and y in turn defined as another two variable, which are s and t. Okay. So if you read the diagram from top to bottom, okay, you can label the edge by del z over del x for the arrow from z to x, flowing down from z to x. And then similarly, when the arrow flow down, okay, you can put the del of the top variable over the del of the bottom variable. Okay. Then similarly, you can do for all of these edges. Okay, let me ask the question again. Why we use del instead of d here? Sheldon, why we use del instead of d here? Okay, 1 and 2 variable, good. 1 and 2 variable, right? Okay, so because we have more than 2 variable defining the function, so we use del instead of d. Okay, so how we read this diagram here? So let's say we want to differentiate z with respect to x. Okay, so you can see that there are two paths here, right? There are two paths here. So when you go along the path, you multiply the partial derivative and you add up two paths. Okay? Okay, so this is how you get the partial derivative of z in terms of x. Similarly, if you want to differentiate z with respect to t, there are also two paths in this diagram. Right? Okay. Hey, actually, I forgot to turn off the light. Can you guys see or not? Do you need to turn on the light? Turn off the light or not? Doesn't you want to turn on the light? It's better, okay. Turn off auto very light. You mean like this? Okay. Okay. Sure. Okay. So you differentiate z with respect to t, right? Okay. So you have two paths to go, right? To go to t from z to t. Similarly, you multiply, you take product along the path, and then you add up different path. Okay. So if you ask, why is this true mathematically? So you need to prove from the definition. Okay, we won't do it here, but I just provide a way to how to remember this. Okay. Hey, speaking about the project, right? I don't think we have time to do assignment 3. Okay. So maybe we cancel assignment 3 and then we make assignment 4 slightly longer. Okay, give you slightly longer time and then slightly longer. And so for this period, I want you to focus on your project. Okay. So give me the draft 1 week before submitting the project. Okay. You can choose to not submit to me, but if you submit to me, then I will tell you what to correct, and then maybe you can get better marks. And then I have better expectation of what you are doing, right? You know the timeline? When's the deadline? Week 10? Yeah, week 10. Okay. Have you guys got the turn it in email yet? Yeah. So whenever you get the draft, right, you just put it in. You can check the plagiarism first. I think it allows multiple submission, I guess. You can just submit until the end then, I guess. Yeah. If it's not, let me know. Yeah, you can submit it first and then check the plagiarism and then you rephrase stuff. Make sense? And then for those who haven't get your topic right, you should decide soon. Okay, you should decide soon. And then let me know as well, so that I got a better expectation. Okay? Okay. Yeah. 雪梅 here or not? 雪梅 not here. Okay. Yeah. Mm. You mean this one? Huh? This one? Okay. Typo. Huh? 3 also wrong? Ah, okay. Yeah. Typo. Yeah. Okay, good. Another thing is, right, uh, I listen to most of your, can I say complaint or your suggestion? Okay, not suggestion to me actually. Not yet. So I so I'll say so this lecture, right? I can't make it. Okay. So from what I hear from you guys, right, there are two type of lecture you attend to, right? So one is like the Liu Jie one, kind of dry, right? And then you say that Darren's one is very good, right? Kind of alive. So what I want to do is I want to mix these two pattern together, okay? Not just, I don't want to just make it until like a public lecture. It's like you listen, hey, you think you know, okay? But actually what is deep inside you don't know. Okay, so I try to mix these two together. This is the experiment I'm trying to do. At the same time, I don't want to like sacrifice the details of max. Okay, so you need to give me suggestion as well. Okay, so you need to constantly give me feedback as well. So I was trying to do this. So I'm trying to put the dry stuff inside, but of course, I will give you more preparation to uh, absorb the dry stuff. Okay. The reason why you can't listen to Liu Jie is because you don't have the I'll say you don't have the you don't have the same, okay. Plainly saying is you don't have the same mind with him. Okay, what does same mind define? The definition of same mind is you don't have the tools, okay, what he used. If you have the tool he used, then you know what he is doing. Okay, meaning you need to be very not to say understand, but you need to know what all definition he is using. Then you will know what he's doing. Otherwise, you'll get lost because you already get lost at the definition. I know your feeling because I was once a student before as well. I also get lost in a lot of classes. Okay. So yeah, this is one advice I can give you. So make sure you understand the definition. Okay. So how to understand the definition? So say, can you explain the definition to your friend or not? Okay. For someone who don't know. Okay. Can you explain, use your own word or use example to convince another? If you can't, then probably you don't understand it. Okay. This is one way to check. Okay. Right. Okay. Continue. Okay. So this is a way to memorize it. I didn't tell you why it is true. If you want to know why is it true, you should prove from the definition. Okay, let's do one exercise and then we'll see how we use this. Let's say we have this function u, okay, in terms of x, y, and z. Well, sure, we jump 3 variable. Okay, how about we skip this one? Should we do this? This is not quite a good example yet. Oh, there's another example. Oh, not here. So let's try another example first. Okay, don't jump too much. So let's try an example. Okay, so let's take a function of xy equals to 3x squared minus y squared. Okay. If you want to differentiate f with respect to x with respect to y, is the usual operation. Okay, let's say we can further parameterize our x and y. Okay, let's say our x is in terms of 2x plus 70 and y is equals to 5st. So try and find how does our f change with respect to the new variable s and t. Okay, let's call our function z so that we can simplify our notation. So we want to find del z over del t and del z over del x. Okay. So remember the tree we draw. Okay. So if we want to find z, the del z with respect to t, what should we do? Okay. What should we do? First, we define z in terms of x and y. Okay. And then x is defined in terms of s and t again. Okay. So not only x possess t variable, y also have t variable. Okay. So you have two ways to go from z to t. Right? Right. Okay. So from top to bottom, every edge you can label by del of the top variable over del of the bottom variable. Okay. So let's just do for the path to t. Okay. Let's just do for the path to t for now. So along the path, you need to multiply, okay? And then you need to add up different paths, okay? If you want to apply chain rule to the composite, not composite, function of two variables. Okay? So del z over del t, you have two paths going to t, okay? One through s, one through y. So you need to go down the path, you need to multiply the partial derivative. I think something's wrong here. Something is wrong. Okay, this is correct. Del x over del t plus del z over del y times del y over del t. Okay, so you can really see that this is an extension of one variable chain rule. Right? Okay, so we just add an extra dimension. Okay, and we replace the d with del because we have more variable now. Okay, so it's really a generalization of chain rule from one-dimensional function of one variable. So what's this? If you want to differentiate z with respect to x, okay, you need to treat all the other variable constant. Okay, so you just get 6x times del x over del t is 7. Okay, plus del z over del y is minus 2y times del y over del t is 5x. Okay. Okay. So are we done yet? Are we done yet? Are we done yet? Are we done? Why not? Eating, is it eating? Are you eating? Eating, right? You're eating. So you say no, right? So why? Why? Just say. Why? Are we done yet? Why? You don't know? But you say no. Why? Why do you say no? But why do you say no? I know. No, no, just say what you think is okay, whether it's wrong or right. Yeah. Okay, good. Okay, sure. Yeah, sure. So you want to express s in terms of s and t and y in terms of s and t. Okay. Is there a reason to do so? Don't know. Okay, so this is why you hesitate to answer, is it? Yeah, it's okay. Just say your thought and then we will decide what happens. Right. Okay. So you can see that there are so many variables here. Okay, 3 variables here. Right. So what to do? Okay, it's kind of messy. Okay, it's kind of messy. So because of this messiness here, we want to like provide a simpler form. Okay, we want to provide a simpler form. So what's the simpler form here? Simplest form. Okay. Since we know that this derivative is with respect to t, okay, it of course makes sense to put something in t here. Okay. And since we also know that we can express everything in s and t, so we might just as well express everything in just s and t. Okay. So we will substitute what is s and what is y. Okay, and then this is equal to this plus 274 t minus 50 x squared t. Okay, so this is not just for aesthetic purpose, but if you want to do further calculation, this form will be useful. Okay, because let's say if you want to integrate this thing here with respect to t, there's nothing here in respect to t. There is actually, but it's hidden. Okay, so it's better you make it apparent. All right. Okay, so make it apparent. Okay. Okay, this is not just maths rule, right? Okay, I'm not just teaching you how to do maths question. We need to make things transparent, okay, so that everyone can follow. Yeah, you got a question. Hey, I thought I am answering this question. What? Okay, you ask clearly again. Okay, okay. Did everyone hear this question or not? Okay, okay. I will answer this. Okay, so this is exactly what I said 5 minutes ago. Okay, what I mean, just now I said, can I stop here, right? So you can see that if you stop here, right, what do you have? You have x, you have y, you have s. Okay, so many variables, right? Okay. First of all, what is the left-hand side here? Is del z over del t. So meaning that this z contains t. But in the left side here, there's no t. Actually, there is a t. Okay, but it's hidden. Okay. So you need to write it out. Okay, let's tell people where's the t. Okay, because later if you want to do computation, you will be doing respect to t. Okay, for example. Yeah, so I mean, you need to be transparent. Okay. Okay, good. Yeah, so if you don't understand what I say, ask again. Okay, I will repeat. Okay, just ask. Feel free to ask. Okay, so another exercise I think we're left as homework. So try and find what is del z over del x. I will provide later. So similarly, you can extend this to 3 variable, 4 variable, 5 variable, 6 variable, and so on, n variable. Okay. So if you extend to, for example, 3 variable, okay, you have a tree with 3 branches. There's a name for this, right? I remember. Oh, but you guys haven't learned graph theory yet, is it? In discrete math. Graph theory. Relation got graph or not? No. I don't know what you're saying. Okay, it's okay. There's a name for this. I can't remember for now. Kind of family tree. You can see that every guy have 3 kids here. Yeah, so there's a special name. So every parent have 3 kids. Every parent have 3 kids. That's a special name for this tree. But anyway, so similarly, if you, for example, you want to differentiate u with respect to t all the way down to t. So how many paths here? How many paths from u to t? 3. Okay. So you will have three terms in your summand. Okay. And then also similarly, when you go down the path, you multiply the edges. Okay. So what does the edges represent? Okay. Let's ask one of you. Kyron. I haven't asked Kyron before. Okay. So what's the edge going from u to x? How you label these edges? Okay, so you will put del u over del x. So you will imagine that this graph, this tree here have orientation going up to down. Okay, and then you will put del of the top variable over the del of the bottom variable to label the edge. Okay. Okay. So in this case here, you have three paths. Okay. So you have del u over del x times del x over del t plus del u over del y plus times del y over del t plus del u over del z times del z over del t. Okay. So you can see that you just add up the additional dimension. Okay. Kind of similar to what happened in vector space. Maybe we don't do this computation here. You can try it. So I just left as exercise. I'll provide solution later. Okay. How about I let you try this a little bit more abstract question. Let you try for 5 minutes, see if you can work it out or not. This question here. At the same time, I will take attendance. By the way, I'm still learning your name. So who is behind Pishon? What's your name? Sorry. Yeah. Really? The name. Someone help to repeat. Are you sick? Are you sick? Oh, Wu Yuqing. How about you? Yeah. Oh, Li Yuanjie. Okay. Yeah, Li Yuanjie. Behind Yuanjia, is your surname Li? No, okay, sorry. Sorry. What's it? Lim Sun Ling. Okay, good. Okay. So you better now? Maybe? Okay. Okay, so beside Sun Ling is Michelle, huh? Beside Michelle, huh? Sorry, I can't hear. Huh? Yu Jiawei, ah? Huh? Li. Okay, oh, you are Li. Li Jiaye. Sorry. Li Ziwing. Oh, Li Jiawen. Okay. Li Jiawen. Oh, Li Jiawen. Okay. Okay, so behind Shunlin is who is the one behind Shunlin? Who are you? Yeah, may I know who are you? White shirt girl. Hey, who is behind Shunlin? Are you? Wong Lingjing. Ah, you are Wong Lingjing. Okay. Lingjing. Wang Lingjing. Okay. Wang Lingjing. Then Sheldon. Yep. Son. Okay. Later continue. Okay. So how it goes? It goes okay. So far so good. Okay. So how to approach this? So how do you read this question here? Right. So you have a GST or GST. GST. So GST is equal to some function in terms of s squared minus t squared, comma t squared minus x squared. Okay. So when we put down this equality here, right, which thing is important? The thing in the right hand side is important. Okay. This thing in the right hand side tell you what is GST. Right. Okay. So this part is important. What is this? This is the function in terms of two variables, right? You have one comma here. But this variable kind of complicated, okay, compared to what we see before. Okay. But it's okay. So one of them is s squared minus t squared. The other one is the minus of that one, right? Minus of s squared minus t squared is just t squared minus s squared. Okay. So is this expression here everything in s and t? Yes or no? Yes, right. Okay. So that's why this g is in terms of s and t. So you also given that f is differentiable. Okay. And then you want to show that this G satisfies this following equation. So why the assumption give you that f is differentiable? Why? Why? Can I remove this? Cannot? Why? Why cannot? Because we need to differentiate f, right? Because when we want to do partial derivative of G, we need to differentiate f. Okay, when we want to differentiate f, we have to make sure our f is differentiable. Okay. So, but differentiable means the tangent plane, right? The linear approximation. So what does it to do with the partial derivative? Why? Yeah, so it's the chain rule. Okay, so you need to know the chain rule. Okay, so why the chain rule is true? It's not covered here. Okay, you need to go and find it. Why is it true? Okay, you can prove it in the project if you like. Okay, so um, so already done this theoretical stuff, so we can differentiate now. So what can we do here? So we have our G. So we start with our G. Okay, and then we have G in terms of S and T, right? Okay. So where's the chain rule in this tree diagram here? Okay, I was trying to do what you might do in the exam or you might do in your exercise. So what happened here? Yeah, so what happened here? How to find chain rule here? Huh? Can't see anything. So I can put del G over del X, right? Del G over del T. So how? Huh? Just like this one. Just like this. Okay, so you can't show anything, right? Okay, you don't know what is del G, also don't know what is del T. Okay, so what to do? Use the right hand side. Okay, or use the F. Okay, use the F. Okay, sure, use the F. So how to use the F? Or you mean start from F? Okay, then what's the child? Ah, okay. Wow, brilliant. Oh. Okay, so let S equals to so let's put this two variable here down here. Okay, so name it X and name it Y. Okay, so from here, X and Y is in terms of S and T. So can I say F and G is the same? Okay, so from here, we will see the chain rule tree diagram now. Okay, so we can put del F over del S over del X over del S, del X over del T, del F over del Y, del Y over del X, and then del Y over del T. Okay. Anyone have problem why we construct tree like this? Or everyone agree? Agree. So easily get convinced one. And you cannot so easily get convinced. Like Wai said, I straight away see your question. I think they are true. I want to prove them they are true. Cannot quite so fast get convinced. Otherwise, you get into trap. Okay. So next, so what to do next? So what you do next is just following the tree. Okay. For example, we want to differentiate G with respect to X. S. Okay. So there are two ways here. Okay. Going from X to S, going from Y to S. Okay. So what you can do is differentiate F with respect to X, del X over del X, plus del F over del Y times del Y over del X. Okay. You compute what is del F over del S? Oh. That's one. This is 1 here. Why? Is F equal to F? Can you slow down a bit? So we start with F S Y, is it? Right. Okay, then you differentiate this with respect to X. Is that okay? So you think that this is equal to 1? Is this what you say? Something like that. Okay. So is this true? F is some function, okay, but we don't know what is it. Okay. So we can't really compute it. Right. So F can be any function, literally. Okay. If this is true, one of it, I think is f x y is equal to 1. Okay, one of the x, sorry, f x y equal to x. Okay, one example, you can get this. Okay, sure. So really, we cannot compute what is f yet because f hasn't given a explicit form. Okay, there's no explicit form in terms of x and y. Okay, so del f over del s times del s over del s is just 2s plus del f over del y. Okay, we don't have explicit form of f, we cannot differentiate. And then multiply del y over del s, which is just minus 2x. Okay, so altogether we get 2x times del f over del s minus del f over del y. Okay, so similarly, for del g over del t, you could just get 2t times del f over del y minus del f over del s. Okay, so we have these two together. Okay, let's try and work out what is t times del g over del s plus s times del g over del t. If this is true, then we are done. Sorry, if what is true? If this is equal to 0, then we are done. Okay, when this is equal to 0, we are done. So this is t times this del g over del s, okay, plus s times del f minus del x. Okay. So what do we get here? So we get exactly the same factor here, del f over del x minus del f over del y. Okay, but the constant here are -1 different from each other. Okay, so they cancel. We get 0. Okay, as desired. Okay. Yeah. Okay. Yeah. Question.
It seems to be plus.
Plus. Where is plus? Where is it? S2T. Where is it? Huh? Wait. Plus. Oh, this is the plus, is it? This is a plus. Okay. So actually, these two are differ by one minus 1. Yeah. Okay. So this two factor is not the same. Instead, 2st is the same. Okay. Yep. Again. Okay. So you want to show that this equation is true, right? Okay. So you need to compute what is left hand side here, because left hand side is everything we know. Okay. We know what is g. Okay. And then we can differentiate g with respect to s and t. Okay. Using the chain rule, right? Okay. So we have computed what is del g over del x. Okay, so we got this here. And then del g over del t on the right here. So we add these two up together. Okay, we add these two up together. So far, okay. How to compute del g over del x? Okay, good question. So how to compute del g over del x? Okay. So how to compute del g over del x? So we know that g is a function in terms of x squared minus t squared, comma t squared minus x squared. Okay, so if you differentiate g is the same as differentiating f. Okay, because those two are the same function. Does it make sense or not? If you like, okay, let me do one more step here. So del G over del X is equal to del F over del S. Make more sense? Make more sense? Okay. Okay. So you happy with the rest? You happy with the rest? Okay. Yeah. Yeah, right. Okay. Okay. Any other questions? Oh. How about we take a break? Okay, let's do one more. Let's do one more before take a break. Okay, let's do one more. So this one we left as a exercise. Okay, we left this as an exercise. This one is an exercise. Let's go to the next one. So we want to differentiate implicit function with two variables. Okay, last time I think we did it before, but now we have this formula here. Okay, so let's say we have a function fsy in terms of 0. Okay, then we want to define y implicitly as a function of x. Then try and find what is dy dx. Okay, because this function is in terms of xy, right, equal to 0. So if you're lucky, you can express everything of y in terms of x. But sometimes you have square root or what, you cannot really take the you cannot really express just y in terms of x. Okay, so what do you do? Okay, so see what we do. What can we do using the chain rule? Okay. So let fsy equal 0. Right. Yeah, let's see how we get this formula here. So similarly, we can differentiate both sides, like what we do in the example just now, because these two are the same function. So we just differentiate both of them with respect to s. Okay. So you differentiate with respect to s of 0, you still get 0. Okay. But now you want to differentiate f with respect to s. What do you get? Huh? You could similarly construct the tree diagram here. Okay. You could similarly construct the tree diagram here. So how this tree diagram being constructed now? Huh? What's del x del y? Uh-huh. Uh-huh. Oh, sure. Del f over del y. Okay. But there's another sentence here, right? Y is implicitly as a function of x. Okay. So x is in terms of x, y can be written in terms of x as well. Okay. So in this case here, we can continue this tree. Okay. So differentiate x with respect to x, you just get 1. Okay. Dy dx, we don't know yet. Okay. So altogether, since there are two paths, so we need to add up the product along the path. Okay. In this case here, we still get this equation equal to 0. Okay. So in this case here, you can see that we can extract this dy dx out, where you get minus del f over del x over del f over del y. Okay. It seems like getting hotter and hotter. Huh? Too hot. So is it okay with this formula here, derivation? Okay. So let's see how we use this. Okay, so let's see how we use this derivation. So example, we have this function here or equation here, right? So this equation here all involve s and y, right? Okay. So can you extract y from x? I mean, can you just write y in terms of x in this case? Separable? Not separable. Not separable. I think it's not separable. Okay. So what to do? Okay, this is an implicit function of y in terms of x. Okay. So we can apply this formula here. Okay. So what's our fxy in this case? We want fxy equal to 0, right? Okay. But how to get this equation? We can simply just move 6xy to the other side. Okay, so this is our new fxy. Maybe you can also ask, can I move s cubed plus y cubed to the other side? Yes, sure. Okay, you can see that both of them should give you the same answer in the end. Okay, so let's do it in this way first. Okay, so you can do it in the other way. So which is 6sy minus s cubed. Okay, so what is dy dx? Okay, using our formula, it is just minus of partial derivative of fxy, okay, which is x cubed plus y cubed minus 6xy over differentiating x cubed plus y cubed minus 6xy with respect to y. Okay, so in this case here we get 3x squared minus 6y over 3y squared minus 6x. Is that right? Okay. Okay. So then you will get after simplification, you get x squared minus 2y over y squared minus 2x. If you like, you can simplify further. Okay, but if you want to stop at previous step, also can. Right. If you stop here, also can. You can see that there are symmetry here. Right. There's a symmetry here. The stopping x and okay. If you want to stop at this stage, also can. In this stage, you can see some symmetry between x and y. So can you from here, can you guess what happened if we do the other convention? Yes or no? If I use a different convention of fsy and then I do the same process, what happened? It's the same thing, but of course you will have some calculation difference, right? Okay, so what's the difference here? Huh? You will have minus on both denominator and extra minus on the denominator and the numerator. Okay, so they cancel. So they will give the same answer. I think so. Okay, if not, you try. Okay, you can try and compute it. Okay, so there's no ambiguity here. Okay, so similarly, you can extend it to 3 variables. Okay, fxy equals 0, and then you can further differentiating z with respect to x and with respect to y. Okay, any questions? Okay, so we will let this exercise as homework as well. Okay. We need to get a bit rushed. Spend too much time here because we lost time to the exam as well. So to pick up. Okay, let's take a break. until 12:15. And we'll continue. One. Hay lần thêm hai bài mà. Yeah. 对，因为它26度嘛。
但是不是不冷，热风扇嘛，吹不吹哦？
等下吹热风出来了。
热稍微稍微，那个什么，
在外面这样。Hey, do you know? Do anyone know where is Soning? Soning, right? Soning. Soning is it Soning or Wensuo? Wensuo. It's Wensuo. Wensuo or Soning? The other guy. Soning. Yeah, Soning. Where's Soning?
Huh?
There's one Wensuo and one Soning, right? Where's Soning? But he never absent one. Why suddenly absent?
This question says this function is only about the u.
Yeah. Yeah. Sure. Yeah. Can. Sure. You can like write this as a minus if you like.
So we don't need to extend as
It's similar. You see, similar. So similar, right? Yeah. Similar. So yeah. So instead of y here, you put minus x. Similar.
Del F del S。
你问的问题跟那个哲学问的问题是一样的。
因为印象中是不可以跟你解释。
没有，但是我解释了啊，你听不懂哈，刚才哦，你不懂这个什么意思啊？这个跟我们那个assignment 题目不是一样吗？如果两个 function 一样的话，他们的 derivative 也是一样，所以他们两个 function 是一样的，我 derivative 是一样就这样吧，就这样吧，看一下。Yeah, so I mean 这一个 line， OK， 这个 line 是因为这个跟这个是一样，所以这个跟这个是一样，因为它们 function 都是一样的，就是一模一样的 function，
OK，
同一个 function。哦，yeah，
就是对于任意一个 series，它如果是这个，我就让它在这个，它都是正的，因为它这个项都是正的。然后我要满足它是 convert 到要比较让它的和必须要小于 make series
小于 harmonic series， 可是 harmonic series diverge 小于它有什么用？
因为它是正好是 condition 的。
你是说 alternating harmonic series？
对，也不是，就是 harmonic series，因为它是因为 alternating harmonic series 是converse，
对，
然后但是它是 harmonic series 不是 converse，而且
对
harmonic series 正好是absolute alternating count，所以说我可以
没有 alternating harmonic series 是absolute 是 conditionally converge，
对，
然后
正好我要满足，如果我要就是正好我满足这个 series 它所有的项都是它所有的 term 都是大于0的，
OK，
那么就必须让它小于那个 harmonic
然后
series，
然后
它就一定是 converse。
对啊，我现在就是有一个问题，harmonic series 不 converge，
对 harmonic series。
所以你怎么用那个 comparison test 说小于它的 series converge？不对，
就我感觉 harmonic theory 它一直是一个那种 boundary， 如果小于它，它就是 converse；大于它，它就不是 converse。
不能，你不能用一个 diverse 的东西去控制一个东西 converge，因为它可以跟它一起 diverge，
知道。
所以你不能够用 diverse 的东西包着一个东西说那个比较小的东西。comparison test 不能这么用。
我知道。
所以
就是我感觉它这个，就是我在去用的 comparison 算
然后
我就是想用那个让那个 series 这个 B N 的 series 它是个 converge， 要满足它肯定小于AN absolute AN。
可是你看，你这个是你的，你看啊，你这句话你为什么要写？喂，
因为我不知道 AN 的 absolute value 到底是大。
我 absolute value，OK，说 AN 等于0 ，CN 等于8 ，we can find I mean 你要 find 这个的话，你要 construct 比如说你要取它们的中间值还是什么这样，你懂什么意思吗？你要干嘛这样看一下？对呀，所以你这个 BN 是要有一个，你讲 we can find 嘛，就是你要证明它存在，所以你就要 construct 出来。你如果要这样的话，你可以说你拿6除3不对，你要讲拿，你应该要拿他们的，可能你拿他们的距离除2，然后因为你知道 AN 是正的嘛，你可以减掉那个距离，懂什么意思吗？你有笔吗？你看，你比如说你要找这个东西嘛，你可以找这个距离，然后你要它strictly还是 equal 的话，不是它可以直接活在 AN 就好了吗？所以这个很危险，所以你can find 你要 find 怎样的，对不对？如果我只找等于呢，等于够不够？
等于如果等于的话，它应该也是
啊，对，所以你要什么到底现在？这样就很 trivial 了哦，这样。所以你到底要什么？
我现在这个
你要 prove 什么？你要 prove 的 statement 是什么？你先写下来先。
就这个，就写这个。
但是你要 prove 什么？如果有这个了，然后什么是对呢？then 什么呢
？BN 也是
then 什么
？series of BN。
OK，我们可以再继续，你先写下来先，我们可以再继续。等一下我要开始先，等一下我们再继续。你先写一下你要 prove 什么先。OK，等一下我们再继续。OK。
Okay, so let's keep going on. Okay, next, we will introduce
directional derivative and the gradient vectors. Okay. So directional derivatives. So there are no reason why we just differentiate along x or y. Okay, literally we can take any direction inside our surface. Okay, any direction. So let's say if z equals to fp, so p is some vector. Okay, so if you like, if you want to keep the keep our notation just now, you can think of it as some xy. Okay, so a point inside our plane is also a vector. How is the point on the Rn is also a vector? Huh? Why is it a point on Rn is a vector? Let's say this is x and use x and y, use x1 and y1. So how is it a point on a plane xy? For example, let's restrict ourselves on R2. Okay, how is it a point on the plane is a vector? Huh? How's the point is a vector? Okay, so it is equivalent to the vector from the origin. Okay, so a point is at the same time a vector. Okay, so you need to be able to swap between these two concepts. Okay, so what do we have here? So the partial derivative of fx and fy in this case, okay, let's say, wow, so many notation coming out here. So okay, so what is I? So I think if you do a lot of computation before, okay, this I is just the vector 1, 0, 0. Okay, which is a vector along a unit vector along the x direction. Okay, and then y, j is a direction on the second variable. So this is not a bit weird. Okay, let's keep ourselves on two variable. So let's keep ourselves on two variable here. Okay, let's live in we live in R2. Okay, let's live in R2 for now. So remember how we defined fx of sy last time? Can anyone recall what we defined this? What's the special function we take? What's the special function we take last time? Okay, I asked Jingbo. What's the special function we take last time? How we define the x partial derivative? Huh? Don't know? Don't know? Ask the next one. Is it 黄雪梅艳？哎，不是，黄雪燕。Okay, 黄雪燕。雪燕。So how we define x partial derivative? Is it 雪燕? 雪燕, right? Okay, yeah. Don't know. Okay. Okay, ask Jiang Chen. Sure, yeah. Calculation wise, we treat y as a constant. So what's the original definition? My question is. Remember the line we take? Getting smaller, smaller, and smaller. So what's that line? How you describe the line? The line is a gradient, right? Yeah, so what's that gradient? Can you recall? Anyone recall? F times x plus h, comma y, and then minus the point over the h. Okay, so what's the difference between these two? Okay, we just write it as a vector form. That's all. Okay, they are really the same. Can you guys see why is it the same? And see, no need to expand for you. You can expand yourself, is it? Okay. Can you not see or not? Hey, why suddenly 眼睛 pop out? You just came, is it? Okay. 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 So, okay, so you can see that this P here, this vector here, is just the point xy, right? Okay, just now we already mentioned how we go from a point to a vector. Okay, this P is just a xy. And then P plus hi is what? It's just adding h in the x direction. Okay, you add nothing in the y direction. Okay, so there's nothing added here. Okay, you already added in the x direction. Okay, these are two equivalent way to say it, but why we prefer this explanation now? Because we are talking about arbitrary direction, okay, arbitrary vector. So what's the definition of directional derivative? So for any unit vector you can take, okay, similar to the x and y vector, unit vector, we can go any direction. So the directional derivative of f at p in the direction of u is just d, okay, the big D, capital D, subscript u on f at the point p, okay, is equal to this limit of this new function here, which is p plus hu. Okay, p plus hu. So meaning you have contribution to the x variable, you also have contribution to the y variable potentially. Okay. Yeah. Makes sense. Okay, this concept is easy, but computation wise might get harder. So for example, in this case here, you got this surface, right? You got this surface, this blue surface here. You can initially we can differentiate with respect to L. Okay, on this line we can check what's the gradient. Okay, right, and then on the x variable we also can check what's the gradient. But let's say we want to go along this t here. Okay, what can we do? We also can check what happened along this direction. What happened to the gradient? Okay, using the definition, right? Yeah. Okay. So the original definition is always hard. Okay, so we need to introduce some tool to help us to calculate. Otherwise, you need to deal with this big limit here. You know, computing limit is very hard, right? Okay, sometimes you need to use L'Hopital rule and so on and so forth. Okay, so we have this tool here. Okay, let's say, okay, so this one I want to prove from sketch. So let's keep this out. Let's prove this. Okay, so let's say your f is a nice function, okay? It's a differentiable function. Then f has a directional derivative in any direction, okay? Once you know that f is differentiable, okay, you can approximate it using a tangent plane nicely. Then f has a directional derivative in any direction. And how you compute the limit? You just take the function at the s partial derivative times the x component of your unit vector plus the partial derivative at y times the y component of your function. And then add them up together. That's all. You can compute the whole limit stuff. Okay. So can everyone see this? Okay. So seems like every function you have, right? Oh, sorry, every direction you have, right? You can just use your partial derivative of x and y to build it up. Okay, something like the basic stuff. Okay, you just use with respect to x, with respect to y. Okay, so why is this true? Okay, why is this true? And let's see why is this true here. Okay, so let's see why is this true. So we can start from the left-hand side. Okay, let's start from the left-hand side. What is du of fxy? Okay, what is this? Okay, what we want to show? Okay, what do we want to show? So let's repeat it so that we are on the same page. So what we want to show is we want to show the formula d respect to f respect to u of xy is equal to fx partial derivative at xy with respect to x times a plus partial derivative with respect to y times b. Okay, so we want to show this. So let's start from the left-hand side. What is this? What is this by definition? By definition, okay, by definition, this is just the limit of f s naught plus, wait, do I want to write s naught here? Okay, let us write xy. Okay, let us write sy. Is it better we write sy? Yeah, write sy. So xy x h a dot y plus hb minus f x y over h when h equal to 0. Okay, so if you forget what is u, let me remind you what is u. U in the question is just the vector AB. Okay, so I translate the vector definition into this point form. Okay, makes sense. Okay. So why this limit here is equal to that right hand side there? Any idea? What? Chain rule? How to use chain rule? Okay. So and then what do you want to do with that? What do you want to do with that? I think chain rule is a good way to start. So what do you want to do with that? Define a function. Oh, you guys got the answer, is it? Okay. Okay, you guys got the answer. Uh, uh, okay. So I was trying like see if we can work out from scratch. Yeah. So see if we can work out from scratch. So what can we do next? What can we do next? Any idea? Okay, what? Wait, so what, wait, so what am I to do? So, what? You go. Sorry? X sum 0, at sum 0, at sum 0. What do you mean by at sum 0? What do you mean by at 0? At 0, like this, at 0?
Minus x plus h y, then minus.
You mean at 1, f of minus what? And then you add another x plus s and y. Like this. Okay, sure. Good. Looking good. Looking good. So why we do this? Why are we doing this? Partial differential with respect to x. Okay. Okay. So what can you see here? Okay. So what can you see here? So what's the advantage of doing this, right? So you can see that this two variable is the same. Okay. But there's the change in y. Okay. So what's this equal to? What's this part equal to? Okay, let me finish this and then write it out. Okay, so what's this? This is differentiating differentiating f with respect to y. Yeah, okay. Okay, but this one is not quite fy yet, right? Because the variable here is s plus ha. Okay, so how? So how? But this part here is what? This part here is done already, right? Okay, because it is y, okay, our fxy, and then change in a. So this is really the fx. Okay, so how? So can we define, so let's define gxy equals to fx ha y. Just y. Is this enough? I think it's this is enough. Okay. Okay. So in this case here, what do we get? So we get g of x of y plus hb minus g of x plus y equal to h. Plus here we can really write as fy at xy. Is that right? So far okay. So far okay. Okay. And then here is, yeah. Sorry. Yeah. What's the problem? This A. Oh, there's an A, right? Ah, okay, so there's an A here. Right, so there's an A here. So there's an A here. It's not just X plus H, right? Sure. Sure. So you want to multiply A here, the top and bottom. Okay. So what is it? How does this help? But there's extra A here. Huh? Say again. Del F del Y. Y. Oh, wait. Oh, I get what you mean. Okay, I get what you mean. Wow, brilliant. Oh, very good, very good. Okay, correct. This is how you make out the A. Good, very good. So you can see if I multiply A and bottom, right? Okay. So you can see that here, HA and HA here match. Okay. But how I get rid of this A at the top? Just move it up. Right, because A is just a constant. Okay. Wow, very good. Oh. You have a potential. So we'll get limit of this guy, H2, go to infinity, go to 0, x plus HA, comma Y minus fxy over AH. Okay, but when we want to deduce, right, this limit here also need AH as well, right? But if H go to 0, AH also go to 0 because A is just a constant. Okay, so now I want to differentiate which one is free variable, which one is bound variable. So this now become very important already. So why we can pull out this A? A is not any variable. This is a fixed one. This is a free variable, which is a constant. So good, very good. So in this case here, what we get on the right hand side is just A times the f of what do we call it? Fy of xy. Okay, but now we still need to deal with this g here, and we still need to deal with this g here. Can we do the similar trick to this g? Don't think so. I mean, for g can or not? Can we do the same trick to g? Yeah, we can do the same trick to g. Okay, so let's do the is it same trick to g or not? Huh? Same trick to g. Same trick to g. Okay, so we can apply the same trick to g. Okay, so we multiply b on top and bottom. Okay, and then we get this b times the limit of going from ph to 0, which is g of x y plus hb. I predict maybe some of you confused already, so please ask. I think some of you confused already, so please ask after I finish writing. Huh? Yfy. Huh? Say again. Oh, sorry. I just write the wrong one. Typo. Okay. So next one we get g with respect to y xy plus a fx xy. Okay. But we got gy fx here. Can we do anything here? Huh? You go to this definition. Okay. So if you want to differentiate g with respect to xy, we also want to differentiate f with respect to y.
differentiate this. Sorry? Sorry? Uh-huh. Are you saying that, let me see, let me see. So when h is going to 0, say again, why suddenly there's a limit coming in? Wait. So okay. So from this function here, right? Okay. I try to differentiate it with respect to y for both. Okay. I get these two equal, right? Okay. So far now it's okay, right? So far now okay. So I can just write here b of fy x plus ha comma y plus a of fx. So right. So what's the problem here? Why we don't just get x? Variable change. You mean? How do you mean? So okay, wait. So what's wrong here? Does anything wrong here? Or not? Don't know. Huh? I use what? I use xy. Huh? I use x twice. Okay, so there's a notation clash here. Is it? Okay, so there's a notation clash here. So let's put this with z. I'll change this to z. Is it better now? Better now? So I change these to z. Change this to z, 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 z. Okay. Is it better? Does it help? Huh? Does it help? So how to get rid of that HA? Huh? Can we what? Chain rule. So how to apply chain rule? It's very what? Is different. It's different. What do you mean? Uh-huh. Huh? Okay.
Is a constant.
Sure.
So help for the relative x publishing.
So
So we can matter what, each passage
Mm-hmm.
that needs to approach. Yeah.
Mm-hmm. Okay, I think I know where's the problem. So I think the problem is we have H here. Okay, we also have H here. Right? So we are letting H go to 0, but here still have another H. Okay, so how to fix this? How to fix this? So I actually have to go back to here. So how to fix this? I didn't change the H to G. What does that mean? Didn't change the H to G. You mean this one? B over B. Yeah. Mm-hmm. You finish one.
From the top part to immediately
B. Okay. Reverse this one. Oh, this one. Okay. Immediately multiply B over B. Oh, I get what you mean. So you mean instead of doing substitution, we just straight away apply the trick we used just now. Is it? Let me think. Sure. 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 Okay. Let's do that. Okay, let's do that. Okay, let's do that. Let's do it. Let's do it. Okay, let's do the trick we found just now and apply to this case here. So we multiply B, B, B here, and then we can transform the B up. And then we get fx plus HA, y plus HB, minus fx plus HA, y over B, HB. Okay, so what's this here? Can we conclude that that limit is just f of x, y differentiate with respect to y? Or no? Can we conclude this? Can we conclude this? Can we conclude this? Can we conclude this? Huh? Limit of, okay, so this thing by definition is what? So this is the limit of fxy, sorry, fx plus hb, sorry, just h is enough, minus fxy over h. Okay, so what's the difference between these two things here? Huh? The x plus ah part. So x plus ah. So what to do? Put the limit in for x only. Can we do that? If you say can put in, so why you think can put it in? Sorry.
Hey, this is like a bit like modeling what happened in your exam. So you are figuring out how to fix things. We will finish after we finish this. Okay. So we have to get this done. Oh, how? How? Hey, Ting Yu, got idea? Any idea? Wow, how? How? Any idea? No. When can you bring limit in? When? Hey, continuous. Continuous, right? Continuous. Okay. Is this continuous? Why? Why is it continuous? Why continuous? No condition here say continuous. Why continuous? So why? Why? There's nothing, there's no this sentence in here. Uh-huh. Okay. Yeah. So this is the extra thing you need, but we didn't mention here. So it's an extra knowledge. So if f is differentiable, meaning f is continuous. Okay. So this is the extra thing we need here. Okay. So since f is differentiable, it's continuous. So we add one more line here. So we can add one more line here. So let me add one more line. This is just equals to f of x y plus hb minus f x plus ha y. Oh, sorry, this one throw away. Of hb here also should become eh plus this a fxy. So remember I say I want to put reason, right? So you need to put reasoning here. Since f is differentiable, f is then continuous. Okay. So since f is differentiable at xy, then f is also continuous at xy. So continuity here need the two variable continuity. Okay, so you need to upgrade as well the continuity. Okay, so what this means is limit of fx plus ha is equals to limit. That is the limit of x plus ha comma y is equal to the f of the limit of h equal to 0 of x plus ha dot y, which is f x y. Okay. Yeah.
If you do this, right?
Yeah.
Then there's the ambiguity for the other one, right?
Which one? The other one is which
F
one?
x plus ha and y plus hb. If you put the limit in.
No. I mean we fix one direction. Fix one direction. This is not y. Maybe I mean. So let's see. Don't clash notation again. Too many things going on. So let me put a z here. Anything works, right? Anything works. Okay. Yeah. So you need to like guess what I'm saying about when I put y or z. But of course, when you write it out, right? So you will need to prevent confusion. Okay. So I put z in this case. Anything you can put in y. Then this one need the definition of continuity. Okay, and then I claim that this is the continuity we want. This is what I claim. I claim. Whoever discussed this, but this is what I claim for now. Okay. Yeah. Yeah. Okay. Confused or not? Okay, still can follow. I think maybe this one is more direct lah, okay? Right? When you want to prove something, right, you will straight away go and compute it. What is it? Okay, I think this is more direct. But if you follow the proof in the lecture notes, this is the trick they always use in analysis. They always like to define a new function and then do something to that function. Actually, what is going on is actually this thing here. So they just make it maybe easier to read. Okay, so what I want to say is don't be carried away by this new function that defines inside the proof. This is really what you need to compute. Okay, so what I present here is a more primitive way to do it. Okay, I mean, yeah, algebraic proof always work like this. Analysis proof always like to define new things. And then you will ask, hey, where you get this idea to define this new thing here? Actually, that new thing is the one that you need to compute. Okay, they just call it a name. They like to give name. Analysts like to give name. I find it. Yeah. If you read the analysis textbook, they always like to define new stuff because they want to call it a name. They don't want to call it a long function. They just give it a name. But algebraic, we just compute. Usually. Okay, so you can try to compare this proof and the proof inside your lecture notes, and then you compare the two. Okay, yeah, compare the two. Any last question before we break? Hey, Zhexuan, got question or not? I think you might have a good question here. Huh? After class? No need now. You need to digest. Or any like quick question you want to ask? No. Don't be afraid, just ask. Because others might have the same question. Okay? No question. No question? So we will continue this computation next time, and then we will see more. Hopefully by the next 3 hours, we will finish partial derivative. Hopefully. Okay. All right, so see you next week. Hey, wait. Don't see you first. I will take the attendance. Wait. So let me quickly go through. Ding Yi, I know already. Well, who's the one before Ding Yi? In front of Ding Yi. Again. Sorry. He Yi. Oh, He Yi. Okay. He Yi. Okay. I always see this name like I thought it's like Pang Chi Fun. Okay, Pang Chi Fun. And then I mean from the left one you can leave already. For the right one, I haven't take center and the right one. Zhu Yanjing. Okay. Zhu Yanjing. Yeah. If you want to take attendance earlier, you can come here. Zhu Yanjing. Next Zhu Yanjing. And then you? Yeah. Oh, Wang Yongzhi. Okay, Wang Yongzhi. Yeah, Wang Yongzhi. Wang Yongzhi. Okay, good. And then Sixian. And then Roy. Eating. and then Jingbo, and then Wu Dongjie, and then Ellie, Ellie, then what's your surname already? Huh? Wong? Ong. On what also 不可以。On 子谦 ，OK OK， On 子谦，Hugh 赛言，对，子言的，说宁哈，哎，sorry，OK， 我错，哎呀 ，keep confusing within these two， 哎呀，文硕 ，OK， 文硕 ，then 离开。And then from the back. Hey, who is beside 朱古力啊？朱古力 beside yeah. 谢宇宙啊 this name also look like a girl name. 谢宇宙 I mean for English. In front is I think I remember. 刘玉伟哈，刘玉伟 okay. I forgot yours. Blue shirt. 吕啊，李佳业啊，李佳业 OK。In front 李佳业 ，Yeah。哦，实验 boy 就 OK。And then 江城。And then Grace, one of you is Grace. The middle one is Grace. Who is beside Grace? 啊？当啊？杨秋还是杨柳青 OK。Beside Grace, another side. 陈啊，这是陈。Bye, can leave now. 陈英奇啊 OK。And then 雪梅 and also 黄雪。Slowly I will learn your name. Then I just share with the notes. Okay, thank you very much. You.
啊。
Yeah.